In this video, we'll discuss about polar coordinates. Now, to understand about polar coordinates, it's very simple. We'll start with a complex number. Z is equal to A plus I into B. We all know that this is the normal complex number and this is a normal way of representing a complex number. This is what we call as the algebraic way of representing a complex number. There is one more way of representing, that is the polar form. Okay, now polar form, we include two important parameters in describing a complex number. Okay, so those are R and theta. R is basically the modulus and theta is what we call as the argument. Okay, so we have two things. One is modulus and one more is argument. Alright, now R is what we call as the modulus and theta is what we call as the argument of a complex number. Now modulus, all of you know, which is root of a square plus b square, correct? So R value becomes root of a square plus b square. Alright. Then theta, which is the argument, is, see here what we do is we represent that real value a value in terms of cos theta and the imaginary part in terms of sin theta. In the sense, what we do is we write a is equal to r cos theta and b is equal to r sin theta. So r and theta is nothing but this r and this theta, the modulus and the argument. Square and add both of them. That's how we get the value of r. See, do one thing, square and add. A square is equal to r square cos square theta and b square is equal to r square sin square theta. Now if you add, you get a square plus b square is equal to r square into cos square theta plus sin square theta. Cos square plus sin square is 1. So we get a square plus b square is equal to r square. That's how you get this value of r as root of a square plus b square. Okay. Now comes the theta value. Do tan theta. That is, divide one by the other. That means what we are doing here, we are going to do b by a is equal to, you basically have r sin theta divided by r cos theta. R and r cancels, you get it as tan theta. So what is theta? Theta becomes tan inverse b divided by a. In other words, we can also tell that theta is tan inverse of imaginary part divided by the real part. Okay, imaginary divided by the real. So in general, if I have to write, so remember that modulus and argument, two important parameters. So in general, if you have to write, then r value is root of real number square plus imaginary number square. So let's write this one down. R value, r is equal to root of the real part whole square plus the imaginary part whole square. This is the modulus r value, and then we have theta. Theta is equal to tan inverse the imaginary part divided by the real part. These two are the two formulas what we are going to use. So let's do one simple example problem. You know, it's gonna make things much more easier for you. Suppose if I tell you that z is equal to, say, 3 plus 4i. Convert this into polar form. Okay, convert this into polar form. So first a value is 3, b value is 4. So r value becomes root of 3 square plus 4 square. Correct? this becomes r is equal to 5. The modulus is 5 and theta is equal to tan inverse of 4 divided by 3. Correct? This is what we are going to get. So tan inverse of 4 divided by 3, which is 1 point something, we get this as around 53.1 degrees. So let's approximate it to 53. Okay. So 53 degree. So theta value is tan inverse of this, which is 53 degree. But this is not over. We have to represent a plus ib in terms of polar form, isn't it? Now, polar form is always represented as r is equal to, or not r, z you can call it. Z is equal to r cos theta plus I into r sin theta. Correct? This is the form. You can take r common. R into cos theta plus I sin theta. Okay. Now we know the value of theta, we know the value of r. Substitute. We get r value is 5 into cos 53 plus I sin 53. Okay, I sin 53. So this is the value of z. The same 3 plus 4i. If you convert this into polar form, we are going to get the value as this. 5 into cos 53 plus I sin 53. Alright. This is converting from one type of complex number into polar form. Clear? So we'll solve more problems on these so that you guys will understand much better as to how do we convert from one form to another, or even vice versa is also there, from polar form to the algebraic form. So we'll do more problems on this, then I think you guys will get a lot more clearer about how it has to be done.